So now we're going to learn about the union of two events and kind of learning about how these circles overlap. These overlapping circles, sometimes in logic, are referred to as Venn diagrams. And so this is like actually, something that is, this concept of circles that contain something and then having those circles overlap, like it could be ideas, contain ideas or whatever. But this idea of having circles overlap applies in many different areas. So it applies in statistics, it applies in logic with Venn diagrams and illustrating how different ideas overlap. Like this could be, conservatives, this could be liberals, and these could be the issues they overlap on, where they share them in common, right? And it also is in databases. When you talk about databases in computer science, you start to look at like union of different data sets, bringing different data sets together. And it's a union of the data sets would be like a combination of all the data sets. So here in statistics, we also have a union of two events. So we've learned about the complement of an event. We've learned about the intersection of an event. Now we're going to learn about the union of two events. And again, here's our sample space. This could be like all 200 students in the example we've been looking at. And then we could have event A, like they're in drama club, and event B, like they're in science club. And before with the intersection, we were just looking to see which ones are in both drama and science. But here we might want to be like, hey, we know the probability of A that somebody's in drama, and we know the probability of B that they're in science. But what's the probability that they are in drama, in science, or both? Like, what's the probability of all that? What's the union of all of this? And so to calculate that, if we know the probability of A and we know the probability of B, we could figure out all this by taking the probability of A, adding it to the probability of B. But then since there's some students who are in both, we have to subtract this from it. Because if this circle is 10 and this circle, if this circle has 10 students and this circle has 10 students and this circle has 3 students, right? Like there's 3 that, or this has 3, the intersection. If we add up 10 and 10, we're going to say that there are, 20 students. But some of the students are in both, right? So if there's 10 in drama and 10 in science, right? But we have 3 that are in both, then if we say there's 10 plus 10 is 20, that's incorrect. Because some are being counted twice. And so to make sure they're not being counted twice, they're in both clubs, right? To make sure they're not being counted twice, we add up the probability of event A, 10 students. We add up the probability of event B, 10 students, or this is doing it with the number of students in each one, but you could do it with the probabilities too. So we add it up, and then we subtract the intersection one time. Because if there are students who are in both, we just need to subtract that number of students once. So if we had 10 here and 10 here and 3 are in both, it's 10 plus 10 is 20, and then we subtract 3 is 17. So in total, the union, the number of students who are in drama, science, or both, would be 17. I just made those numbers up, by the way. So, and we're going to see that explained here. But the basic definition of a union is the union of events A and B is the event containing all sample points that are in A or B or both, right? The union of events A and B is denoted by A union B. Here is ChatGPT's definition. The union of two events A and B is denoted as A union B, representing the event that either A, B, or both occur. It includes all outcomes that are in either event or both. The union is used to calculate the probability that at least one of several events occurs. It helps in understanding overlapping probabilities when dealing with multiple events. If you roll a die, let event A be rolling an even number and B be rolling a number greater than 4. The union of A and B would be even numbers, 2, 4, and 6, plus numbers greater than 4, which is 5 and 6. And notice we didn't list 6 out twice, even though 6 is greater than 4, and 6 is also an even number, right? The union of this is we're just like 2, 4, 5, and 6. And we didn't include, right? We took away from or subtracted from what's in the intersection, which would be anything that's even and greater than 4, which is 6. So we took that extra 6 away, right? And we just said, here's the union, it's these. So let me further illustrate a union by giving you a sample problem here. So here's the union of two events. Imagine you're at a college where students can choose to enroll in different language courses, Spanish or French. The college has Spanish and French, right? There's 2 different language courses. College has 150 students in total. out of these, 45 are in Spanish, 35 are in French, and 15 are in both, right? 15 are in both. What is the probability that a randomly selected student is enrolled in either the Spanish course, the French course, or both? So what is the union, right? That they're enrolled in Spanish, French, or both. So here's the probability of A union B. We have the probability of A, which is going to be 45 out of 150. We have the probability of B, which is going to be 35 out of 150. And then we're going to subtract the intersection of A and B. And so we'll have subtract 15 out of 150, because we have to take those students who are in both, because we're double counting them. We have to take that amount away so that we don't double count them, right? Because they're in both circles. So if we just add up both circles, we've added these students twice. And so to account for that, we're going to remove those students from our calculation once. And so we subtract the probability of the intersection of A and B. But let's read through this and see how ChatGPT explains it. To solve this problem, you'll need to calculate the probability of the union of the two events, being enrolled in the Spanish course or the French course, right? Let A be the event students in Spanish, B be the event that they're in French. We're going to do the union of A union B represents students who are enrolled in either Spanish, French, or both. Calculate the number of students in the union. Use the formula for the union of the two events, AB minus the intersection of AB. Number of students in Spanish event is 45. In French, event B is 35. Number of students in both Spanish and French. Intersection AB is 15. Calculate the total number of students in the union. A union B, 45 over 50, right? 35 over 150, right there, minus 15 over 150. And then we get 65 over 150. 65 over 150 is 13 over 30. 13 over 30 is approximately 43.33%. So the probability the randomly selected student is enrolled in either Spanish, French, or both is 43%. This problem helps you understand how to calculate the probability of the union of two events, which represents the likelihood that at least one of the events occurs. So sample space, events, figuring out all that. You know, the union, you just have to remember to subtract, add up everything in event A, probability or numbers or whatever, add up to everything in event B, and then subtract the intersection once, right? Subtract the intersection once. So that's the union of two events.